Hello, listeners. Welcome to the second season of the Unlocking the Energy Trilemma podcast. Today, Ravi from the US, Jam from Spain, and our guest, Simon Michaux from Finland, debate about energy transition from another angle. Simon is a senior scientist at the Geological Survey of Finland in the Mineral Solutions Unit. He worked 18 years in R&D for the Australian mining industry and later as a researcher in Liege. Today, we will talk about the twin challenges of the scarcity of technology minerals and the transitioning away from fossil fuels. Ravi, Jose, over to you.
Thank you, Ava, and welcome, Simon, to the Unlocking the Energy Trilemma podcast.
Hello.
So let us start with the same first question we asked to all our guest speakers, which is, please give us a data or a figure that you think is relevant in the energy transition and which could be related with the energy trilemma.
Okay. So in the energy transition, we're going to electrify everything. So we need copper. Okay. So for the last 4,000 years, say from 2020 back to 4,000 BC, the human species globally mined 700 million tons of copper.
700.
Now, 700 million tons. Now, to keep up with existing demand, the way things have been for the last couple of decades, we will mine the same quantity in the next 22 years. So there comes a point when it's going to get harder and harder to deliver that. However, to electrify everything, to phase out fossil fuels and electrify everything, that's another task that we have not considered. This is a step change. And we need a step change of 6.1 billion, with a B, tons of copper to electrify our existing economy to the point where we don't need fossil fuels anymore. But that's to maintain our existing footprint, or how it was in 2018. If we were to expand, it will be larger again. So our current reserves, what's called a mineral reserve, which is like a economic feasibility study, is 880 million tons. Resources, where there's a patch of ground that it's mineralized a bit above background, we're not quite sure what's there. It's estimated, and this is with a capital E, 2.1 billion tons. So we're not even halfway there with all the metal that we know of on planet Earth just to stand still. At a very fundamental level, we need a new plan.
Wow.
Simon, just to get to the basics, what minerals are most critical for the green transition, in your opinion?
Human innovation is a thing. We can problem solve our way out of almost anything. And so a lot of the figures I've actually put together now is what battery chemistries we think we're going to use and what's coming into the market maybe 10 years from now. So that's where these numbers have come from. Someone could pull a rabbit out of the hat and they might be able to make a battery out of, say, graphene, for example, carbon, but that will require energy. But every single system I've looked at, let's say we knock out lithium. We don't need lithium, we don't need cobalt, we don't need nickel. But every single system I've looked at needs copper. I think that everyone needs nickel and everyone needs graphite. So that's the electrification side of things. Yeah, I would say copper is the most critical at the moment until someone pulls a rabbit out of the hat.
So in your view, copper is the most critical, and you have others like lithium and cobalt and nickel and some platinum group metals, perhaps graphite. Are these also considered minerals that are required for the energy transition in some form?
So these are metals. These are metals. So a mineral is like a mineralized piece of rock that's made up of a chemistry that we're going to extract the metal from. And you've got like a spectrum of minerals behind each metal. So I've got this in a set of tiers. You've got one or two metals at the very heart of everything that we cannot do without. You've got things like copper, you've got iron's another one, you've got nickel and everything. And the next ring out, you've got like in Europe, we have what's called the critical raw materials list, and the United States has now got something similar, and China has something similar. Now, that's all based on economic value versus potential scarcity of supply. All of that is based on the way we are now. Take away fossil fuels, and that entire list gets turned on its ear, and our priorities will have to shift. So at the moment, when fossil fuels goes down, the best game in town is electric vehicle batteries and hydrogen fuel cells. Okay, at the moment, we need lithium and cobalt to do that, to make, say, an electric vehicle battery. Can we make a battery out of sodium or fluorite instead? The answer is yes, but now we need the time to make an infrastructure to build that. we need like a good 10, 20 years to build out the infrastructure for that. And we need the energy to make all this stuff. But we've got a step change of construction. And so I'm giving you a confusing answer. Sorry about that. This is a systems-based thinking where you've got lots of things connected together. And if you make one change, it pulls on everything else. Now, we've got a number of those issues right through the materials value chain, all the way from the raw materials you pull out of the ground to smelting metal, to making manufactured goods, to getting those goods out to people, and then disposing of the waste at the other end.
You wrote a fantastic report titled The Estimation of the Quantity of Metals to Phase Out Fossil Fuels in a Full System Replacement. And everybody could think that that replacement will be led by solar photovoltaic panels and wind turbines. Will we have enough raw materials and critical materials to deliver the amount of solar panels and wind turbines to achieve that goal?
I don't believe so in our current form, but if we were to change some of our form, we might be able to evolve past some of these bottlenecks. It comes down to, first we've got to manufacture all this stuff. Now, to manufacture a solar panel, you take high quality quartz metallurgical silicon. You've got to heat it to 2,200 degrees Celsius to make the silicon wafer. At the moment, that's mostly done in China, and most of the time they use coal. So your entire solar panel chain is attached to a fossil fuel to function. There's that side of things. Then there is wind and solar. Is Achilles' heel is they're both highly intermittent, right? That they're both highly variable, and so they need to be buffered by something. For example, when the sun goes down, wind and solar doesn't work. Conventional thinking believes that buffer should only be 4 hours. Where they get that is the gaps between supply and demand over a couple of days. You've got you only need 4 or 5 hours to be kept for a couple of days, but they're not looking at the day-night cycle. 4 hours won't get us through a single night. Then you've got the difference between summer and winter. In winter, solar panels don't work as well because there's less sun radiance. And so you get like this dip that lasts for a very long time. And so your power demand has to come from somewhere else. And so conventional thinking hasn't really picked up on that. And so when I actually went out and talked to some planning policy planners, I was, we'll get it from battery banks. That's fine, battery banks. How many battery banks are we talking about here? Because they haven't done the math of replacing fossil fuels. How big is this system? And when anyone's looked at this, they've only looked at their own little patch, their own little backyard. We haven't understood that this is a global market, and that global market has to be stitched together in size, and everyone in the world's got to arrive there together, or we turn on each other, especially since the manufacture of these goods happens from a very localized place. One place in the world controls like a large proportion of, say, solar panel production, China. One province in particular. And that's just the economics of how things have worked out. And so when you actually put together that buffer and add that buffer, that's where like a big chunk of my calculation has come from, trying to put this on the ground. Until we actually learn how to store a large amount of power, the wind and solar for an extended period of time, wind and solar aren't viable. Now, the current thinking in the proponents who actually support this idea would like to believe that wind and solar can be buttressed by each other. You can support, when the sun goes down, the wind is blowing somewhere. You often hear that. And then vice versa. Problem is, both of these systems are highly irregular and erratic. They just don't cooperate. And so we're talking about a massive overbuild and lots of transmission lines, which will require much more material inputs to do all those sorts of things, so we don't have the battery buffer. We've also got the problem of what happens when we have, say, a wind lull that can go for, say, 4 or 5 days. At the same time, it's winter when the sun radiance isn't very good. And if we have a couple of these things together, we haven't got our arms around the fact that the weather is variable. Our entire society at the moment is based around the idea that whatever we want happens at the snap of a finger, and it just arrives. Like I click on a website, it arrives. We don't have to wait for anything. But when we actually become dependent on the weather, all of a sudden that all falls over. So the simple answer is, in the current form of the system as we understand it, we will not have the resources or the manufacturing capacity or the time or the money or the intellectual capacity, as in trained professionals, to deploy that many solar panels, wind turbines, and support systems.
A two-part question. Are current extraction methods sustainable to meet some of these long-term energy goals? And I think you addressed that partially in your previous answer. And secondly, what about the economics of mining? The CapEx, OpEx, environmental and regulatory costs. Are there any specific challenges or supply chain risks that you see in these areas? Can you just shed some light on that at a high level for our audience?
So mining and extraction at the moment is very fossil fuel dependent. It's very much, rate's been decreasing. Humans, like any other biological organism, we're going to go after the good resources first. The high grade, small, easy to get to resources, they all go first. So 200 years ago, all the high grade copper and gold and all the other mineral stuff, that was taken out. And over time, rate's been decreasing, and we've been able to get by increasing the size of the operations and using economies of scale and engineering innovation to deliver increasing amounts of material to the market. Bigger is better. And that's been fine while cheap energy has been available. But now energy is becoming more expensive. So on one hand, where our energy systems, say a century ago, were really large and high quality, like the Gawa deposit or the oil gushes in Pennsylvania, but now we're down to oil tar sands in Canada. And so we've got like an upside down pyramid. Next to the upside down pyramid, we've got our mineral resources, where a century ago we had very small, high quality resources that didn't take much to get hold of. But now we've got these massive open pits, really low grade, that we've got to shift tons and tons of ore just to get a single ton of metal. And so when these two things meet, it's not that we run out of resources, we run out of money. We're not going to run out of resources ever. Our ability to extract those resources fast enough, cheaply, is what will hit the wall first. And then we've got to think of something else. The current mining industry at the moment is dependent on fossil fuels, and they're looking at, quite seriously looking at, moving away from fossil fuels. Now, a lot of their equipment is electrified now, and they've worked out a way of doing the truck and shovel fleet that's now electrified. The performance metrics are different though, which means the economics are different. I've yet to go through the numbers to show this. Trouble starts, where do you actually generate the electricity? And can you generate the electricity in large enough quantities at high density reliably? A mine site needs, like a process plant might have, say, like a 30 megawatt installed SAG mill. Like that's one mill, 30 megawatts. It needs that power to be consistent 24 hours a day, 7 days a week, to a millisecond resolution. Now, if we're going to deliver that with wind turbines and solar panels, then we need a buffer between the two to do that. And can we do that reliably in all weathers? And that's the conversation where it all falls down. And that's when I start reaching for the unorthodox solutions. As for CapEx is the capital expenditure to start a mine. In the good old days, it could be just a couple of friends, a couple of mates with shovels, and they start digging in the backyard and they get this nice little bit of gold or metal, or they go panning in the creek. Then there was a point where you needed someone with capital because you started to have to build infrastructure. Then we got to the point where we need a corporation to put millions of dollars of capital on the ground. Now it's billions. And in the current environment at the moment, when a mining company starts, they've got to start in partnership with the local government. And the local government's got to be talked into building infrastructure, things like roads, ports, railways, what have you, to support the idea of mining so much material and getting electrical power out there and potable water. Now, when we start a mine, the shareholders put up 30%. The rest comes from a hedge fund. So the mining industry lost control of the mining industry about 30, 40 years ago, and it's now controlled by hedge funds, the banking sector, who also own the oil sector. Mines have gotten bigger and bigger and bigger, and it's not about resource stewardship. It's about let's make as much money as possible in the short term. But they're getting longer and longer term operations. It might take now 10 years to get a mine operational because of their size. You've got to get the stripping ratio down to the ore. There's all sorts of issues like that now that they've got to deal with. And the copper industry in particular, we're not running out of copper deposits. They're just low grade at the moment. They're having problems getting capital, like getting someone to actually raise capital to you've got to put something like $4 million on the ground to get a mine started, in South America somewhere. So 4 billion. And it might take 10 years to start producing. These are big operations. And now we've got a situation where the market is so volatile, you might not get your money back. So an investor goes, why would I do that when I can put my money in the stock market, say Walmart, and get the same result in 6 weeks? And so now we've got the problem of getting investor appetite to actually put on the ground to get mine sites going. Because it's all about money, and money is short term, and money doesn't care about sustainability issues and doesn't care if things fall over and break up. And if we start having systems break down, that's a buying opportunity for someone. This is the logic. And this is the mining industry has been struggling for some time, and they've been doing their level best to become more efficient and more effective and do things responsibly. And it's gotten more and more challenging as time has gone on. And I can see an era where it's going to get worse and more challenging until we all understand what really happens now. And we go back to thinking, we're going to start a mine and we're going to think 100 years into the future about this mine. It's going to be a nation state that does it in partnership with the corporation, with that context. And it will be about who gets the metal and what for, not putting it to the market.
Simon, this is very related with the geopolitical current situation. We can listen to President Trump in the news about Ukraine, rare earth materials, and so on. China currently dominates the global supply chains for rare earth elements and key battery materials. Which are the risks of Western economies face in their energy transition? Is it possible to mitigate their dependence on China?
It is possible, but we've got to see our throne as the most sophisticated economies in the world. We've got to go back to the drawing board, and most Western economies, for example, have shut down any industrial capacity, and we're now a service-based economy because reasons. Not in our backyard. We don't mining in our backyard. We buy things from the market. Right. The countries that own the companies who do the mining are now our geopolitical adversaries that are thinking in terms of payback for what happened a couple of centuries ago. So we've now got to take the time to go back and rebuild. And so we've got to rebuild the entire value chain. And like Europe, for example, is a largely untapped mining frontier because by the time they exported mining to the colonies, mining could only go down 100 meters or so. So most of Europe has not been surveyed below 100 meters, which means there's multiple world-class deposits here. But imagine, if you will, someone found a very rich deposit of stuff to be mined under the Cologne Cathedral. Imagine the arguments about, should we mine this or not? We're not the leading economies in the world. This is what America is doing. In fact, both political sides in America are doing the same thing. When the Trans-Pacific Partnership failed in 2008, that was supposed to be the replacement of the petrodollar agreement. But what they were trying to do is integrate all economic activity away from China to flow through the United States and then back out again to everyone. So if you like the economic reason to be. When it failed, the Americans, the oligarchs that control, all the interest groups that control the United States said, we have now got to re-establish our industrial sector. So the Biden campaign had Build Back Better, and the Trump campaign had Make America Great Again, but it's actually the same outcome. You've got to build your own infrastructure domestically again from scratch across the board. You've got to bring your interest groups from all over the world, contract them back behind your domestic borders and re-establish a strong foundation again industrially. And so the Americans are trying to do that. There's the politics side of things, and the Chinese, I believe, are playing their own chess match quite successfully, and Europe should do something like that, but our member states can't agree on the color of an orange. So we're unlikely to get anything going there. But that's what we've got to do. We've got to establish not just sourcing of raw materials, but the infrastructure to take those raw materials, turn into something useful. These are the challenge, and this will take time. We're talking 50, 60 years of development here if we're allowed to do it.
So we're reaching a hard stop, and I'll just ask one more question before handing it over to Jose. In your opinion, with all these challenges, how can a circular economy or recycling help prevent shortages and alleviate some of these hindrances that you have cited?
So, like, circular economy is the best game in town, but it needs to evolve. Steady state economy is the same basic. Industrial ecology is what it used to be called. It's thermodynamically imbalanced in its current form and doesn't include enough. And we've got to look at a complete metamorphosis of our industrial system, where what we do with our materials from a design point of view, we design things to be recycled. We first scale back on what we need to run our society on a smaller number of components that are simplified in complexity to the point where we can manufacture them locally. They're designed to be recycled. So when they go offline, we recycle them. And so we have better control over our waste management. Our society at the moment is not really geared for that. Now, because we've got to rebuild society to do that, we're talking about a step change in construction. So we've got a massive spike of resource consumption where we build a new system, and on the other side of that spike, in theory, we've got a society that's a bit more stable. So we've got to be more conscious about the material flows that we've got, but also the energy flows. What is energy and what does it do for us? And if we managed our energy and our materials the way we manage our money, we'd be a whole lot more careful about it. What I'm saying about that is we're very careful about where every dollar goes. If we're losing money, we will track that down and fix it. What if we started to manage our resources the same way? So whether it's actually called the circular economy when we get to that point, to me, it's going to be called something else. I now call it the resource balanced economy. So it's going to evolve. The simple answer to your question is it's not going to work in its current form, and we're not entirely sure what it would be. But we've got to have the conversation to go down that chute of development, because it's the best way forward.
Well, Simon, thank you very much for your participation. Let's close this episode with the same question we asked to all our speakers. Is if you had a magic wand, what would you do to unlock the energy trilemma?
So this might sound odd. In fact, you might laugh out loud. It would change us. I would change our perception. The magic wand is waved, and now every person in our society has a better situation awareness across all issues. At the same time, we have a better understanding of what is real and what is illusion, because we are awash with a vast amount of information, most of which is low quality, and a lot of which is antagonistically, maliciously wrong. If we can clear that up, and we as a society can now understand exactly what our net position is, what are the solutions going forward, we can start to change our shape and form to move towards a series of solutions. And from that point, everything else will come.
I'm not sure if with only one magic wand will be enough to get your desire, but we will try. Simon, thank you very much indeed. And we'll encourage all the people to read your report and the conclusions of that report. Thank you.
Thank you very much, Simon.
You're welcome, mate.
We hope you liked this conversation. Follow us on LinkedIn or subscribe for free to the podcast on the platform of your choice, Spotify, Amazon, YouTube, or Apple. Because in the next episode, Ravi and Jam will speak with another expert in the industry to unlock the energy trilemma.